Hey everyone. We're going to be covering the last Edpuzzle of the semester. So before I get started, I just want to say I really appreciate the hard work that you put in the semester. We're almost done, and it's been a great semester, and I really appreciate the time that you've taken to watch these videos and suffer through some of the smaller mistakes I make in these videos and letting me know and learning as I'm learning with you. So this week we're going to study two types of sequences, arithmetic and geometric sequences in series. So we're going to first kind of delve into this first video, the difference between an arithmetic and a geometric sequence. So when we take a look at this first sequence, 1, 3, 5, 7, it is called arithmetic because I am adding a common number each time. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on and so forth. So we call this common thing that we are adding, we actually call it a common difference. And how we calculate a common difference is just by subtracting any two sequential terms. So if I take 3 and subtract 1, I get 2. 5 minus 3 equals 2. And finally 7 minus 5 also equals 2. So our common difference here is going to be 2. And then A1 indicates the first term in the sequence, and that is 1. Now the reason I am finding my first term and my common difference is now that I have that, I'm going to use this formula over here to find the nth term in the sequence. That way if we want to know something like the 50th term in the sequence, it's going to be easy to calculate. So the nth term of the sequence is given by the formula a sub n is equal to our first term, which we just found is 1, plus the difference, or the common difference, which is 2, parentheses, n minus 1. Now we can simplify this. If we distribute the 2 in there, it's going to be 1 plus 2n minus 2. Let's combine our like terms, 1 minus 2. So the nth term of the sequence is given by the formula 2n minus 1. So if you're asked to do something like find the 25th term in the sequence, we can say it's 2 times n is 25 here, right? Minus 1. 2 times 25 is 50 minus 1, which is 49. So if you extended this sequence all the way out to the 25th term, it would be 49. All right, let's take a look at another arithmetic sequence. This one is negative 1, 3, 7. Okay, so it doesn't really seem like this would have a common difference, but once I start calculating this, let's take a look. 3 minus negative 1 is 3 plus 1, which gives us 4. 7 minus 3 is also 4, right? So we know the common difference is 4. We know this is an arithmetic sequence because it does have a common difference. And we know the first term in the sequence is negative 1. Let's go ahead and find the nth term of the sequence. A sub n is equal to our first term, which is negative 1, plus our difference, which is 4, parentheses n minus 1. Opening up these parentheses, we're going to get negative 1 plus 4n minus 4, which will give us 4n minus 5 for the nth term of the sequence. Again, if I needed to find a term in the sequence, I would first get the nth term, and then I would plug the number in the sequence I was looking for into this formula. All right. So now we're going to be taking a look at geometric sequences and series. These are ones that have, instead of them being a constant addition, they are going to be a multiplier. And actually, I need to clarify there's actually a mistake on this one. So I'm going to rewrite it as 7, 14, 28, 56, ... continuing on forever. Now, these you can see 7 times something is 14. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. So rather than adding something at a regular interval, we are going to be multiplying. Now, what we are multiplying by we call the common ratio. And just like an arithmetic sequence, we find the common ratio by dividing two terms in the sequence. 14 divided by 7 is 2. And 28 divided by 14 is also 2. So we know the common ratio is 2 here. And the first term in the sequence is 7. And we have this formula right here to help us understand what the formula for the nth term is. So if we want to find a sub n, it's going to be the first term, which is 7, times our common ratio, which is 2, to the n minus 1. So let's say I wanted to find the 11th term in the sequence. To find the 11th term in the sequence, it would be 7 times 2 to the 11 minus 1, which is 7 times 2 to the 10th power. And 2 to the 10th power is a massive number. Geometric sequences in series grow a lot faster than arithmetic sequences in series. So this would be 7 times 1024. And 7 times 1024 is 7,168. So if you were to work this geometric series out more, you'd be able to find that the 11th term is 7,168. But it asks us for the nth term in the sequence, so that would be our answer here. Find the nth term of this sequence. Now when you're just take a look at it, you see, this one's decreasing, isn't it? All the series and sequences we've seen up to this point are increasing. This one is decreasing. This is called a convergent sequence because it is converging to a specific number. We're going to study this in a little bit more detail in class. We're not going to go too deep into convergent sequences in series here, but I want to show you that this does have a common ratio. So if I divide 2 and 6, that gives me 1/3, right? And if I divide 2/3 and divide 2, I also get 1/3. So we can see the common ratio here is actually 1/3. And that's why this is decreasing, because you are multiplying each time by a fraction. We also know that the first term in our sequence is 6. So to find the nth term of the sequence, again, we're looking back up to the formula. We're going to take the first term, which is 6, and multiply that by our common ratio, which we found was 1/3, and then we raise this to the n minus 1 power. Again, from there, we could go find different terms in the sequence.